My name is Phuong. In this video, I'm gonna explain the two advanced features in my website of the unit COS30043. Firstly, I'm gonna tell briefly through the scenarios, the definitions, the traditional problems, then why we need to use them, and I will show you guys the comparison directly on the code and websites. For the first ones, I want to mention the retrieval augmented generations or RAG model systems. We can see this in a lot of Vietnamese productions with the situations that users don't want to read the long, complicated documents, instructions, or searching for information in the websites. Instead, we can provide them with a chatbot features to answer them on all of their questions. A simple method that we can use is just to call an API from LLMs such as OpenAI, Gemini, or Claude. However, there will be several big problems. Accuracy and hallucinations. Well, it's obvious that LLMs nowadays tend to tell us fake information instead of telling the truth that they just don't know about the user's question. About the domain knowledge, Core API cannot answer users' questions about our websites, although they can have modern search tools to go to search other websites. But my deployed website cannot go through the SEO, the search engine organizations of Google's, and therefore it mostly cannot read the information in my websites. The next is the cost problems. So this is the code for using API key of OpenAI. As you can see, it's quite expensive. Just imagine I use the Nano one. In one prompt of one users may cost about $0.1 because we need to scan a lot of website informations. And one day they may prompt 10 times. So 1 month it costs us about $30. So it's okay to solve less than 10 users. But if imagine we need to serve 1,000 users or even more. And so the amount of money we will spend for these chatbot features will be colossal if we just call an LM directly. That's why and delivers the RAG model systems. It can be defined simply what that we still call API and use LLM for answering questions. But the information we deliver to LLMs is the documents we prepare previously. We're gonna cut the documents into chunks of informations, vectorize them, and then put them in database. When user give us some questions, we just need to compare the query to the top 5 most related chunks in the database. This process is the vector calculations. They are all calculated by computers, so it will be really fast and cost no money. And finally, we just throw the top 5 chunk of information to LLM to summarize the answers. That's the only cost that we need to spend. Now I'm gonna move through the real process of chunkings and chatting with the chatbot features. Here I'm at the admin, so I'm allowed to upload documents, and I have prepared several documents for the websites. As an admin, I have prepared some frequently asked questions, and I just upload it. When I upload, it will call the APIs from the form. It will call the APIs, and it moves to the upload documents. Here is where the API is called, and from there we will move to the go through the post documents, go to the post uploaded documents APIs, and the document will go through the ingestion pipeline. Ingestion pipeline has several functions such as participant document or create chunk titles or summarize chunks, and from that we'll upload it to the superbase, and also the vector database is storage. From that, we can see in the log I have printed out, it had created 11 chunks for the document that I have just uploaded. And for that, we can go to now when I'm users and I have some questions related to authentications. Maybe we can add ChatGPT first to tell us the general questions of the websites. Um, Here, uh, it it will obviously don't know what is the website that I'm accessed. It's just giving some guess, and it's not actually the information of my websites. However, I could ask this one for the chatbot, the direct model, because this is the chatbot that based on the document that I prepared before. So there will be informations that we need. Here, this is just the information that I located on the file that I prepared before. Now this is just a brief compute of the cost that may be spent for normal LLM and RAG models. It costs less than 300 times, which means we can serve 1,000 users in 1 month with only $33 instead of $10,000. And these are examples. For the cost that I just spent over 1 month for learning about RAG and Asian, just $0.36. Now moving on to the next part, high volume transactions. Is a common problem in reality when users want to improve our website's scalability and extendability. When we receive huge numbers of requests and when serving lots of users, our websites would be collapsed by choking database or crashing servers. Moreover, users cannot see their change. Maybe they like the news post, they comment on a post, and they see nothing when they refresh the page. This will affect badly to the user experience. That's when we need the terms of catch and queue. There are other services with stronger execution such as Amazon SQS or Elastic Cache. But in this assignment, I just use Redis for catch and RabbitMQ for queue. About definitions, with a Q1, it's simple that we will create a place for all requests to copy with one by one, so no request will be lost. With a catch, I use catching method for two purposes on these projects. The first one is to catch the like, comments, and follow of users, even the records in database has not been updated yet. So they can see their change immediately on the website. The second one is to catch the user information for a certain amount of time. To the next request of users will not be required to be authenticated. Now move to the code. Here I catch the like, comments, and the follows request of users. And I also apply the LRU or least recently used and Pareto principles of 20 and 80s. The reason for this technique is that if we have 10,000 users, is the problems we cannot catch them all and make changes on the websites for 10,000 likes buttons. Instead, only the most 20% most popular status receive the catching solution because they will attract users the most. For the 80% others, they will just wait in the queues, except for the situations that users want to refresh and see, and they change immediately. That status will be pushed to the first line. And here is the Here is the thread test simulators, where I can create a Python file to push large numbers of real requests to the servers. Firstly, I will just, here you can see I just run the back end, the front end only, and I will create 1,000 requests maybe. And for this, I have not run any catch and kill yet. It will create a new users and access on the news post that I created before. As you can see here, it will really slow by commenting one by one. So after about 20 minutes, we can see that the database is choked, and well, the successful request is only 10 out of thousands, with 1%. It's really low. Now I'm gonna turn on my Redis and RabbitMQ. And I turn on the workers on the back end. Now I will wait for the backends ready, and I will push again with the same number of requests, the same queries. And we can see, you can see the backend is really fast. And also I'm gonna access the RabbitMQ interface to show you the evidence that it's copying with high volume transaction here. And you see, I don't need to stop the videos. I just wait for about 10 to 20 seconds. 100% of requests has been successfully delivered. So that is how I can cope with high volume sections problems in the scenarios with Redis and RabbitMQ.